This lesson on covalent compounds is going to teach you how to name them from a formula, and if I gave you a formula, how to make the name. Our first objective is, if I give you a chemical name, what is the formula? And if I give you the formula, what is the chemical name? So those are our two objectives for today. Okay, our first objective is to teach you, if I give you a name, how do I write the formula? So how do we transcribe a name into a formula? So the chemical name tells you a lot of things about the formula. It tells you which atoms are in the formula, which atom is listed first in the formula, and then how many atoms of each are in the compound. In other words, these are the subscripts. The first element listed in the name is the first element in the formula. The second element listed is the second part of the name, and will always be in the "-ide" version of that second element. So in other words, remember we talked about oxygen, it would be listed as oxide, nitrogen, nitride. We're going to introduce these Greek prefixes before each root word to tell us how many of that thing or that atom is in the compound. I'll show you the demonstration on the next page. All right, here are the Greek prefixes. Each Greek prefix is associated with a number. So let's look at the first Greek prefix, which is mono. Mono means one. Now, if you have the first element and there's only one of them, you don't write the word mono. But if the second element in the formula is only one, you do write mono. So there's a little trick there, and I'll get to that in a second when we get to the actual trying these out. When you have two of something in a compound, the word is di. Di would go before the name of that particular thing. So it would be like dicarbon or dioxide. Tri is 3, tetra is 4, and you can go down the list here and see them all. Now you'll see that some are capitalized and some are not. That's just by happen chance. There was no reason for doing that. However, I will say that if one of the prefixes starts the name of the compound, in other words, it's at the very beginning of the name, you will capitalize the very first letter. Anything else after that is not capitalized. So you do not capitalize the start of the second part of the name. Right, and I'll get to that when we get to that actual thing. Okay, there's a lot of words on this slide, and these are looks like it's a lot of steps, but once you do it once or twice, you realize there's more words on here than really what you're actually doing, right? So how do we translate a name into a formula? Well, we're going to look at the name first. The first word in the name is going to represent the first element in the chemical formula. We're just going to, right now, disregard any Greek prefix that goes with that name, and I'll get to that in a second. So you're going to look on the periodic table and write the chemical symbol for the first element written. So for example, if the first element was in the name was carbon, you would look up on the periodic table and see that carbon is C. So you would put that down as the first part of your chemical formula. If it was nitrogen, you would just write N. And then we're going to look at that first Greek prefix, which will precede that first name. And that will be either di, tri, whatever. And we're going to associate that with the subscript for that first element in the compound. Now remember, if there's no word, if there's no Greek prefix, it means that there's only one of them. We don't write mono for the first element. We just write the element and then make sure we know that that's one. So if there's no Greek prefix, that means that there's only one of that atom in the compound. Then we're going to repeat steps 1 through 3 for the second word in the name, which will give us the second element. Remember that the second element name will end in "ide." So we have to translate it back into the correct chemical symbol for that thing. So oxide means oxygen, so we look up on the periodic table and that would be an O. Selenide would be selenium, and we looked up that on the periodic table and that would be Se. Right? Now, in this case, there will always be a prefix associated with the second name, second part of the name. And whatever that prefix is, that's how many of that particular element there are. Now, again, if you see the word mono, that means that there's only one of that atom, and we do not write a subscript of 1. We just leave it as is. If it's di, tri, tetra, whatever, we correspond whatever that Greek prefix means in a number, and that is the subscript for that second element. All right, and there's some examples here. Carbon monoxide, for example. Okay, so let's put those steps into practice. So here's my first name, and I want to convert that into a chemical formula. So I look at the first word, and the first word is carbon. So I look on my periodic table, and I see that carbon is a C. So I'm going to put that right here. And I see that there's no prefix associated with it, so that means that it's only 1 as far as the subscript, and so I do not write a subscript of 1. I just leave it as is. Now I look at my second word, and the second word is oxide. I know there's a di in front there. We'll get to that in a second. And oxide stands for the "ide" version of oxygen. So we're going to look on the chemical symbols from our periodic table, and we find that oxygen is a O. Now we look at the prefix for the other word here, and we see there's a di. And I look at my chart, and I see that di means 2. So when I go to write my prefix, I'm going to write 2 for my subscript for the oxygen. The prefix for the oxide tells you how many of those oxides we have in the chemical formula, and that means 2 for this case. So there I have it. I have CO2. Now the next one is tetraphosphorus decaoxide. So again, we're going to look for the root word of the first element, and that would be phosphorus. I'm going to underline it right here. And I know that there's a tetra in front here, and we're going to get to that in a second. So I look on my periodic table, and I see that phosphorus has a chemical symbol of P. Now, this one does have a Greek prefix in front of it, and you notice it starts with a capital letter. So I'm going to underline that in blue, and that's tetra. So that means that my P, my phosphorus, is found 4 times in the chemical formula. Okay, so we're done with the first element now. Now we go to the second element, and we see here that oxide again. So that means O. So we're going to put that right next to it, just like we did in a formula. And then we're going to look at the prefix in front of it. There's always going to be a prefix, and that's deca, and that means 10. And so that would be the subscript for that. And the last one is, you'll see it's kind of funny on this one, it's dihydrogen monoxide. So again, what are we going to look for here? The first element is listed, and it's hydrogen. So we're going to write an H. Now before we move on to the second word, we have to see if it has a subscript associate that. And we're going to look here, and it says di. So that means I have 2 of these. So I'm going to put a little 2 right here. And I'm done with my first element in my chemical formula. Now the second word, again, is oxide. Okay? And that means O. And there it is. And we also have this mon. Now, it doesn't say mono because you generally don't write monoxide. It's just monoxide. You take away one of the O's, and so it translates down into monoxide. So that means that there's only one of them, and there you go. So in the case of water, the actual chemical name, if you were to say it using the Greek system, is what this is called, it would be dihydrogen monoxide. But nobody ever calls it that. They just call it water. So the real name for this is not dihydrogen monoxide, it's water. All right? So there you go. That's how you would go from a name to a formula. Now it's quite simple to go the other way. You have a formula and then now you want to write the name. So it's just the reverse process. You just break it down just as you did before, except now when you go to it, you're going to be writing words instead of chemical symbols. So look at the formula and determine the full name of the first element, and then write it down. If the first element has a subscript, determine the Greek prefix for that number, and then write the prefix word as the prefix for the element word. For example, subscript is 4, then you would write the word tetra. Subscript is 5, you would write penta. If you have a subscript of 1, or there is no subscript, you don't write anything. You just leave it as is, right? For the second element, you're going to look at the subscript and convert it to a number in the Greek prefix. That's going to write down first. Then you're just going to translate the element name into the I'd version and then write that as the second element part of the name. All right? Don't leave no space between the Greek prefix and the I'd version of the second element. So let's try it on the next page. Okay, so here we go. We have CCl4. That's a Cl4. It's not Ci4. It's not CCI4. So the first element, we're just going to underline it real quick, is right here. And that's carbon. So we're just going to write carbon. And there's no prefix for it. And there's no, so that means that there's only one of them. So it's carbon. We're going to leave a blank. And we're going to look up the second. We're going to look at the subscript right here. So it's kind of a little bit backwards from what you just did. We're going to look at the subscript first, and that's 4. And so when I go to my Greek prefix, that means tetra. So we're going to leave a space and we write tetra. That will take account this right here. That gives you how many of those. And then we look at the Cl, and we find out that's chlorine. And chlorine translates to chloride. So we just finished the word with chloride. And there we go. We're done with that. Second example, P2O5. So again, we look for the first element, and that would be the P. And so we would write phosphorus, the full name as it is listed on the periodic table. And now we see that we have a 2 here. So we have to write the word di in front of the phosphorus. So it's diphosphorus. Again, we leave a space between the diphosphorus and the next part of the name. And we look here, and we see a 5. And we need that's Greeks mean penta. So we write penta. And then oxide. And then we write oxide. Oxygen is oxide. Now, sometimes people will write it as pentoxide, pentoxide, or pentaoxide. Whatever works for you easiest. But the preferred name is pentoxide, but if you write it pentaoxide, that's fine by me, right? So it would be, the full name would be diphosphorus pentoxide or pentaoxide. Okay? Again, usually when you have 2 vowels, in A and an O, and for the oxide, you just leave it as it. You take one of the vowels out. And the last one on this side is NH3. So again, we look for the first element, and there it is, N. So we just go to our periodic table and write the full name of that element, nitrogen. And we see that there is no prefix with it, so it means that there's 1. We leave a little space. We look at the subscript for the second element, which is a 3, and that translates to tri. So we put the word tri first. Then we go to the element, which is hydrogen, and that translates into hydride. And another name for this, or the more common name for this, is ammonia. Ammonia. So nitrogen trihydride, or the more common name, so this is the common name, just like water. So the common name is ammonia. The chemical name would be nitrogen trihydride, right? And the last one, again, we're getting pretty good at this now. We're going to look at the first element, and that's carbon. So we just write carbon. We do see that there is a subscript with the carbon. So we have to go to our table, Greek table, and we see that's di. So it's di. Let me make that a little nicer. So it's di-carbon. Leave a space. The next thing we're going to look at is the subscript for the second element, which is a 4. That translates to tetra. And then the last thing would be the oxide. Now I've given you mostly oxides, 1 chloride over here, 1 hydride. But you know, this rule applies to the nitrides, the sulfides, anything like that. So there you have it. You've got dicarbon tetroxide, diphosphorus pentoxide, nitrogen trihydride, aka ammonia, and carbon tetrachloride. So that's pretty much all you need to know. That's pretty simple. You can go do some practice on it now, but it's pretty straightforward once you get the process.